All right, we'll see if this works this time. I'll keep trying. Okay, we want to talk about our unit circle in quadrants. So obviously we know this is quadrant 1, and we go counterclockwise, quadrant 2, then down here is quadrant 3, then down here is quadrant 4. So we're going to talk about in each quadrant, what is the sign, S-I-G-N? So that means, is it positive or negative? That's what that means. Of each function in each of the 4 quadrants. So let's start with quadrant 1. So I have some point in quadrant 1, x comma y. In quadrant 1, we know that the x value is always going to be positive, and the y value is also going to be positive. So now when we go through and name our trig functions, well, we know that sine is the y. So my y value, my y coordinate, is just going to be positive. We know that cosine is x, so that's just also going to be positive. Tangent, it's y over x. So that's a positive over positive, which would just be a positive. Cotangent is the reciprocal of tangent, so that's also positive. Secant is 1 over x, positive. All right, so what do we notice about quadrant 1? Everything's positive, all right? That all of our trig functions in quadrant 1 are positive. We love quadrant 1 because everything turns out nice and positive. So what I'll say up here for quadrant 1 is we'll say that all are positive. Okay. Let's go to quadrant 2. All right, so what happens when I graph a point in quadrant 2? What's true about the coordinates? X is negative, y is positive, right? Because my x I'm going left, my y I'm still going up. Okay, so any coordinate there would have a negative and then a positive. All right, so how's that going to translate here? Well, my sign is still y. Y is positive. Cosine will be negative, right? Because that's x. Tangent is y over x, so I'll have a positive divided by a negative, which will give me a negative. And then these reciprocal functions go with each other. So if tangent is negative, cotangent will always be negative. If cosine is negative, secant will be negative. The reciprocal function goes with its original function. So cosecant would be positive because sine was positive. Okay? So out of the first 3, which is the only one that's positive? Sine. So for quadrant 2, I'm going to say sine is positive. What you're going to try and memorize is the ones that are positive in each quadrant, okay, because it's going to be different. So quadrant 1, all is positive. Quadrant 2, it's sine. Quadrant 3, what's true about my coordinates? They're both negatives, right? So sine is negative, cosine is negative, but what about tangent? Positive, because you have a negative divided by negative, right? And a negative divided by negative would be positive. And then the reciprocals go with their original function. All right, so what do we notice again about the first 3? The only one that's positive is tangent. All right, try quadrant 4. Quadrant 4, my x value is positive, my y value is negative. So I get negative, positive, negative, negative, positive, negative. So again, among those first 3, the only positive was cosine. All right, so there's a way to help you remember this. Okay, so if we start up here, it's all. Then it's just sine, then it's tangent, then it's cosine. So the little mnemonic device that we use to remember this is all still stands for all. S for sine stands for students, tan T stands for take, and cosine C stands for calculus. So all students take calculus. You all will be signing up for calculus next year. No questions asked, right? So all students take calculus. Just a quick way to remember, if I'm in quadrant 1, it's all quadrant 2 students. So it's sine that's positive, cosine, or tangent, and then cosine, okay? This will help you to remember which quadrant, what one's positive, which one's negative. Why do we care, Mr. Rodriguez? Believe me, you'll care. We're going to do an example down here, this next example, and this is where it's going to come into play, okay? Questions at all on that and the signs? Pretty easy to memorize, right? Okay. And then I just remember that the reciprocal function goes with it. So not only is tangent, but its reciprocal function, cotangent, would also be positive, right? All right, so let's go to this next example. Let point P be a point on the unit circle, and there'll be questions similar to this on your quiz tomorrow, so you got to be able to do something like this. So I've got my unit circle. Point P is a point there. It says the coordinates are 1/3, y, and P is in the first quadrant. So I have to go somewhere in the first quadrant. This point P, 1/3, y. Evaluate the 6 trig functions. Okay, but the 6 trig functions, I need a y value, right? Like if there's no y value, sine is supposed to be y. Well, I don't have a y value. So my first step is I got to figure out what y is. How am I going to do that? You guys got thoughts on how I'm going to figure out what y is? Pythagorean theorem. Sure, let's try it. So I would drop down, this is one way. It's all kind of related actually. And make a little triangle here. What's this bottom length down here? That's 1/3 because that's my x value. This vertical length is the y that I don't know. What's the value of my hypotenuse? 1. This is a unit circle. The unit circle, your hypotenuse is always equal to 1. Okay? So now I can just do Pythagorean theorem. 1/3 squared plus y squared equals 1 squared. And solve it for y. Perfect. This equation is also an equation that we've seen before. Yes, if you go back a page, right here, the equation of our unit circle, look at that. It was x squared plus y squared equals 1. That is literally the exact same equation we just used. The x coordinate was 1/3. The y coordinate we don't know is equal to 1. Okay, so it's all related. So if it's easier for you to just memorize this formula and use that, right, and then plug in the 1/3, you're doing the same thing. Or if it's easier for you to think about it visually with a Pythagorean theorem, you can think about it that way. All right, so anyways, either way you go about it, what do you get for y? No calculators allowed. Okay, when I solve for y here, I'm taking the square root of both sides, so we've been well trained to do plus or minus 2√2 because the square root of 8 becomes 2√2 and the square root of 9 becomes 3. So you should get, you guys with me when I solve this? Somehow? Minus 1/9, minus 1/9 gave me 8/9. Square root of both sides, plus or minus. So now this is where you get to pick. Is your y value a positive or a negative? Yeah, you got to look at the quadrant. So this is where the quadrant matters, right? And so since I'm in quadrant 1, that y value is going to be a positive. If I was down here in quadrant 4, guess what? The y value would have been a negative. Make sense? All right, so since my y value is positive, then I'm going to just pick, I'm going to get rid of that part, right? And just pick the positive. All right, so now I can figure these out. Sine is y, so that's what I just found. Cosine is x. Well, they gave that to us in the problem. That was 1/3. Tangent is y over x. I got to do a little work here. Okay? So I'm going to do a little work. I got to take y, which was this big guy, 2√2 over 3, and divide it by x, which was 1/3. It's a little complex fraction, which means I can multiply by the reciprocal. They cancel. So tangent would be 2√2. But a lot of you are going to have to do that work off to the side to simplify these fractions. All right, cotangent is the reciprocal of tangent, right? So if I know this is 2√2, I would just take its reciprocal, which means I would do 1 over 2 root 2. But that's not rationalized. So I got to multiply by root 2 over root 2, and we get root 2 over 2 times 2, which is 4. So you do have to rationalize all these, simplify them, okay? Secant is the reciprocal of cosine. So 1/3, flip it. I just get 3. And then cosecant is the reciprocal of sine. So I'm going to flip that, but I still got to rationalize 2 times 2. So 3 root 2 over 4. And then this is when you're done, you kind of want to go back and check your signs. Well, since I was in quadrant 1, all students take calculus, quadrant 1, all are positive, so everything should be positive. Nice and easy. Okay. Try this one. It's the same type of problem, but now I'm in quadrant 4. Do you have to draw a picture? No, but do some of us like it because we like to see things visually? Yes, that's fine. Especially if you're going to do a triangle and try and do it that way. Otherwise, you can just do your x squared plus y squared equals 1. Sometimes I give you the x value, sometimes I give you the y value. So you just kind of got to read carefully. All right, go ahead and solve it. And yeah, you got to be able to solve this whole thing without a calculator. What do you guys get for y? Yes, square root of 7 over 4. Is it positive or negative? Negative. Good. You should have gotten square root of 7 over 4. Let's see. If you didn't get that, we got to figure that out because little mental math here without a calculator. Remember when you're squaring this fraction, you do square both the top and the bottom, so you would get 9/16. And then 1 is really like 16 over 16. And so then when I subtract 9/16, right, y squared would equal 7 over 16. Square root, technically it's plus or minus root 7 over 4. But since we're in quadrant 4, that y value is going to be negative. So I would pick negative root 7 over 4. And that's my y value. Your x value is obviously 3/4. All right, I'll give you a couple minutes to work out the rest of them. A lot of room to work it all out. Sorry. Kind of crowded in there. All right, let's see what you got. Tangent should have been negative root 7 over 3. Okay, after you simplified, canceled, right? cotangent was the reciprocal of that, so that would just be negative 3 root 7 over 7. Sorry, I said 7 and wrote 3. Negative 3 root 7 over 7 after you rationalize. Secant would just be 4/3, and cosecant would be negative 4 root 7 over 7. You're going to get really good at rationalizing, working out fractions, taking reciprocals. A lot of stuff you just got to get to do. You can be able to do it by hand. Check your signs, right? This is quadrant 4. All students take calculus. Calculus is C cosine. So quadrant 4, the only thing that should be positive is cosine, and it's reciprocal. All the rest of them should be negative, 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 negative. Okay? Those negatives, if you got that first one right when you were solving for it and you put the right sign, then your negatives are all going to come out as you're working through the problem. But you might have missed one or forgot one somewhere, so you just got to be careful with that. Questions? All right, turn the page, and let's do the last part. This part is calculator allowed, so take out your calculators. This is one of the only things we'll do with calculators. So you don't do this too often, but I will put it up here. The first thing you want to do is check your mode, okay? So in order to use these, the calculator will evaluate for you. Now, granted, like it's 239 degrees, right? That's not on our unit circle, right? Your unit circle just has the 30s and 45s and 60s and stuff. So if I ask you to do sort of a strange one like this, that's when we would have to use our calculator, okay? So you want to go into mode first. So when you hit that mode button, and you arrow down, notice that radians and degrees are your option here. The default for all your calculators is always radians. So if you change your batteries, if it gets reset for some reason, if you drop your calculator and it resets, it's always going to go back to radians. So for those of you in physics, which is most of my juniors, right? In physics, you're always doing degrees. So you got to start being really careful checking that, right? Like if you're in my class and we're doing stuff with radians in the calculator, then you go to physics to take a test, and your calculator is still in radians, and you didn't switch it back to degrees, you will get everything wrong in physics, okay? Or vice versa. You're in physics working in degrees, you come to my class, and we're doing radians, and you didn't switch back. So just make sure you're switching back and forth up there, okay? So for this first one, notice it says theta equals 239 degrees. So my calculator needs to be in degrees. And so I'll go over and switch it. And I can quit out of my mode. All right, so to find the sine of that theta, 239, I literally press the sine button, which is right down here, right? Press sine, and I do 239, and I hit enter. And this is very difficult. Okay, let's round to 3 decimal places. All right, so then to do cosine, oh look, there's a cosine button. I just press it. 239, nice and easy. Negative 0.515. And then, oh look, tangent. There's a tangent button. Mr. Rodriguez, why are we doing this? This is too easy. Well, it gets a little harder. All right, the next one says cotangent. And uh-oh, there is no cotangent button. All right? So what some people think, which is not true, is that I can just get this tan to the negative 1. The inverse of tangent is what that is. So I can just hit second tan, and that'll give me cotangent. Not the same. This is the inverse of the tangent function, which is, we'll use those later when we're trying to find the angle measure. That's different from the reciprocal function of cotangent. So in order to do the reciprocal, you literally are going to type in your calculator 1 over the tangent. Right? So you're going to type it in 1 divided by tangent of 239. Does that make sense? So for cotangent, I have to type in 1 over tangent. I get my answer. I round. For secant, I literally type in 1 over cosine. And you can like go up and copy it if you want. Right? So negative 1.942. And then cosecant, I literally have to do 1 over the sine. So 1 over sine. And I get my answers. Just make sure you are getting the same answers I'm getting or close to it. Otherwise, there's something off with the calculator. Make sense? So that's really what I wanted to show you. Okay. For this next one, it says 2.53. Notice there's no degree symbol. So what is our mode? Radian. So go back into mode, switch it to radians, and then you can just figure all those out. 2.53 cosine. Okay, so these are pretty easy. And you can kind of check your signs. We'll talk about those in a second. Just make sure you're getting the same answers I'm getting. Good. Let's talk about the positives and negatives here. Right, we just talked about all students take calculus. So let's go back to this first one, 239 degrees. Where is that? What quadrant? Yeah, quadrant 3, right? Because this is 180, this is 270. So 239 would be somewhere over here. So all students take. Tangent should be the only one that's positive. We'll look up here. Oh, look, tangent was positive, and it's reciprocal. Cotangent was the only one positive, right? Where's 2.53 radians? This was like 1 radian, right? That's like that 57.3. 2 radians is about here. 3 radians is about here. So where would 2.53 radians be? About here. That's quadrant 2, all students. So sine should be positive. Sure enough, sine and its reciprocal are the two that are positive. Right? So that kind of just reinforces what we learned. Okay, I think that's it. Stopping this video.